All right, my wonderful students, let's start learning about distance and displacement. So there we are. So let's say you're walking somewhere. Let's say you're starting at Towson, that start point, and you're ending at your home, that end point. You take a long meandering path. You've covered a lot more distance than the direct path between them. In physics, we care more about that pink line, which is the direct path. How far the end is from the start, straight line. That's called displacement. And that's a key physics idea. Distance, we sometimes use the letter x for it, but not really that much. Displacement, however, we definitely use the letter d or delta x. Delta's a little triangle. So let's label those 2 points, xi and xf. Initial point and final point. That's the I and the f. So when it comes to displacement mathematically, displacement, d, or again delta x, is actually the final position minus the initial position mathematically. So let's look at the number line to make sure. Let's say we start at -1 and we go right 1 to 0. The starting point's -1, the final point 0. So the displacement, which is the final minus the initial, if we do the math, we end at 0, we start at -1. You end up with +1 for your displacement. We went positively 1 unit. Now let's say we go forward 1, but then we turn around and go back to -2. The overall displacement is your final minus your initial of the entire journey. We started at -1, but we ended at -2. If you do the math, you end up with -1. We ended up left 1. However, we still went some distance. We went forward 1, back 2. That's an overall distance of 3. So to summarize, displacement is the change in position, delta x for our symbol. Distance, however, is just simply how far you actually went. Displacement always needs a direction as well. In the previous 2 cases, we've used positive or negative. The first case was +1. The other case was -2. We could also use the phrase left or right. Distance, however, is always just a number. Notice the last answer wasn't 3 left or 3 right. It was just 3 overall. However, both distance and displacement can have what we call segments as well as an overall value. So let's see what I mean. Let's kind of slow it down a little bit more. So here's a set of walks you're going to do. Let's say you take 1 step forward from some point. Then you take 2 steps forward from that point. Then you take another step forward from that point. And then you turn around and walk 3 steps back. Imagine this is the number line. And to do that, we're going to make a table, our first of many, let me tell you. 1, 2, 3, 4 are the 4 walks we did. And at the bottom, let's write down the total, which is the sigma, which is a Greek letter. It becomes very important. Let's label our initial and final points for each segment, as well as the displacement, delta x. Now, we don't know what point we started at. We can just give it a random number. So let's say that the starting point is 0. Now, in the first segment, we went 1 forward, so we ended at +1. We're now at +1. We go another 2 forward, we're now at +3. So for the next segment, we're still at +3. So let's write it in for our initial point. And we go 1 more forward, so now we're at +4. So we're about to start turning around. We're still 4 away. We turn around, go 3 backwards, so now we're at +1. So what's our initial and end point of this entire journey? 0 is our start point, our end point's +1. So our displacement's +1. And our individual displacements for each of those segments are those. Notice 1's negative because we turned around. The overall displacement is +1. The individual displacements are listed above. Come in class, I'll see you tomorrow.